Yeah, so I'm sorry. So I thought I'm unable to find out the link and all, some problem is came. So I'm sorry for this. Yeah, can we go ahead now? Can we go ahead now? Can we go ahead? Is audio is okay? Is audio is okay? Is audio is okay? Is audio is okay? Please verify audio is okay or not. Yeah, thank you so much. Sorry for late, right? I am there in some other some other platform because I am unable to find out the link, right? Yeah, it's not my mistake, but anyhow, mistake from my side only. So let's try this. Yeah, what is the answer for this? Let T be a binary search tree with 15 nodes. The minimum and maximum possible height of T are. Note height of a tree with a single node is 0. Height of a tree with single node is 0. Let T be a binary search tree with 15 nodes. The minimum and maximum possible height of a tree. The height of a tree with single node is 0. Right? So what is the answer? It is a binary search tree. Please be careful. It is a binary search tree. The minimum and maximum possible height of a single node is 0. So I think because the 15 nodes are there, if 2 nodes are there, maximum height is 1. If 3 nodes are there, maximum height is 2. It is the maximum. And if you want maximum, keep everywhere minimum. If you want maximum, keep everywhere minimum. And if you want minimum height, keep everywhere maximum. If you want minimum height, keep everywhere maximum. I think this will goes to minimum, right? So what is the height here? Levels how many? 1, 2, 3, 4. 4 levels are there. Height is going to be 3. 4 levels are there. Height is going to be 3. Right? Height is going to be 3. And one more thing, 15 nodes are there. Height is going to be 14. Height is going to be 14. If 3 nodes are there, height 2. If 15 nodes are there, height 14. Height 14. So I think problem is over. So minimum is going to be 3. Maximum is going to be 14. So B is the answer for this. Many people said answer is B. Right? Right? Fine. So what is your question? I don't know. So related to which one? Which topic? Your question? Your question is related to which topic? Let T be a binary search tree with 15 nodes. The minimum and maximum possible height of T are. Right? So I think answer is going to be 3 and 14. 3 and 14. 3 and 14. Can you check this? What is the answer of this? What is the answer of this? Consider the following code segment. The minimum number of total variables required to convert the above code segment to static single assignment form is. Okay, let's see that. Consider the following code segment. Some code segment is given. The minimum number of total variables required to convert the above code segment to static single assignment form is. So So first try to minimize, because he is asking minimum number of temporary variables. See this one, minimum number of temporary variable, minimum number of total variables, minimum number of total variables required to convert the above code segment to static single assignment. He is asking minimum, right? If any possibility there, we will do that. So see this one, see everyone now, I think from the bottom onwards you have to start, right? X means replaced by X possibility, X means replaced by X possibility, right? If we replace X possibility, I think nothing will cancel. If we replace X by X possibility, that is the Y plus W, right? Y replaced by Y possibility, I think nothing cancel, right? Nothing cancel. Next one, if we replace Y by Y possibility, here also nothing is cancel. If we replace T by, right, T possibility, nothing there. Z by Z possibility, I think nothing there. So no one will be cancelled, no one is going to be cancelled, right? No one is going to be cancelled. So let's see one small line. No one is going to be cancelled. Let's see one small line. So X into Y first, from the bottom onwards, X into Y. Let me check, minimize it. Why? Arey. Which one? What laughing? Yeah, first see, try to minimize if anything possible. If minimization is not possible, write as it is. See this one, X into Y. What is the X possibility? So what is the Y possibility? Y possibility is going to be, right, T minus Z. Y possibility T minus Z. Here star already there. Can you say what is the X possibility? X possibility is going to be, right, Y plus W. Right, this is the current status. I think this one you completed. See, nothing cancelling. The purpose of this one is cancellation. So cancellation is nothing there until here, right? And one more. I think these things completed. Next one. What is the Y next Y? What is the next Y? X star V. Right, X star V. So this is the current status still here, you completed. So I think Y is going to be X star V. Is there any X here? I think X is here, right? Let me write W star T minus Z. Now X is there, so Y replaced by X star V, X replaced by U minus T star V plus W star T minus Z. This is the expression. Indirectly, directly, this is the expression. Right? Now follow priorities, whatever he is saying also. Just follow priorities, whatever he is saying. What priorities he is following? See, nothing cancel, I know. Right? Follow priorities, whatever he is saying, without changing the priorities. Right? You have to evaluate this expression. See that one. Which will be done first? From bottom onwards you have to do now. Which one will be done first? Right? If you want, you can keep brackets also. Because of nothing cancellation is possible, let me keep brackets so that, see, you cannot do whatever way you want. Just follow the order. See this one. See everyone now. So if you see from this side, X into Y first, that's okay. But what is the X? What is the Y? Y is going to be T minus Z. This will be done. This is going to be, I think, right, X is going to be Y plus W, like this bracket, right? Keep the brackets properly. Next one, after completion of this one, right, inside Y, what you done? Inside Y, so Y plus W will be done first, okay? So inside Y, what you done? X plus X into V. x into v. Next one, x into v, that's fine. Next one, I think x replaced by u minus t, u minus t. So just follow priorities, nothing there, just follow priorities. Now start one by one. Cancellation not there, cancellations also not there, right? So just follow according to priorities. Keep brackets properly, first x into v, afterwards plus w, like this, plus w also, okay, fine, right? Next one, this x replaced by u minus t, afterward this will be there anyhow, bracket, afterward this is also there, that is fine. Then t minus z is already there, so that nothing wrong will happen, nothing wrong. See this one, first one, directly I cannot minimize. See, directly minimize. What is the meaning of directly minimization? Here x into v, somewhere also x into v, that is the direct minimization. Direct minimization no way. Indirect also, what is the meaning? By substituting cancellation if anything is there, cancellation also not there, Now lastly do like this, substitute and brackets also keep properly. After completion of all, let's start one by one. So who will be done? U minus t. See, without priority changing, who will be done? U minus t will be done, right? Let's start one by one. U minus t, right? U minus t. Let's see this one, u minus t. So everyone listen, t1 is equal to u minus t. This is the first one, temporary variable, I used it. U minus t is t1. Next one, with that one into v, t1 into v, it is t2. This is the second one, completed. Next one, with that t2 plus w, it is t3. This is also completed. Next one, t minus z is equal to t4. It is a static single assignment. Here you cannot give whatever you want, right? All should be different. Left side all should be different. This also completed. Next one, lastly, t5 is equal to what is the answer? t3 star t4. It is the t5. So finally 5 temporary variables are there, plus 5 temporary variable, right? Plus 5 temporary variable. Let's see the remaining people. Also listed out. 5 temporary variable, remaining people also listed out. What are those remaining people? Right? I think u, t, v, w, z. I think 5 people. So 5 temporary variable, temp 5. 5 is a normal variable. Total is going to be 10. See, all possible minimizations I done. See, all possible minimization. What is the first one? Direct minimization possible, check. Direct minimization. What is the meaning of direct? X into v. Anywhere x into v, exactly like that, check. So direct not there. Next one, indirect. What is the meaning? Any cancellation possible, check. Indirect. By substitution some cancellation. Indirect also check, not there. Now lastly you can do like this, substitute, right? Anywhere I can change it, anywhere, right? Common expression if you can do. I think sometimes what happened is without doing this also you can give, but safe side I done this, safe side I done this, right? Direct you check, indirect you check. If any minimization possible you do this, right? After completion of all, right? So you can do the safe side, you can do. If you don't do also, mostly no problem. Sometimes maybe problem will come. That's the reason I want to go for safe side. I done this. Just to substitute properly. Keep brackets also. See, keep brackets also. Everyone know this one, right? Replace y by y possibility. Replace x by x possibility. Afterwards again y by y possibility, right? X by x possibility. I replaced now, right? After replacing all, so do brackets properly. So brackets wise one by one you go. If you want to do directly, you can go. That is also okay. At the end, wrong cannot happen. You can go directly also. See this one. It is the number 1 I done. Inner bracket will be done. Next number 2. Next number 3. number 4, lastly number 5. So 5 temporary variables, static, right? Static single assignment, left hand side how many people? Those many. So afterwards remaining people also count. See, U different, T different, V different, W different, Z different, right? So normal variables are 5, temporary variables are 5, totally 10. Totally 10. Check once. Yeah, that's what I am saying. See, DAG, right? DAG, right? So see this one. See everyone now? Direct minimization possible, do. Indirect means cancellation. Cancellation possible, do. So nothing is there, then substitute like this. Right? Without substitution also you can do. Right? Safe side I done this. Substitute properly. At anywhere any minimization is possible, please verify. I didn't find out any minimization here. Right? First minus, next V, next W. First minus, next star, next plus, next minus, next star. So some people are asking, sir, I will do directly. Means I will do directly. Directly how? Let's see. Let's see how directly. See, let's see how directly. If anyone want to do directly, maybe sometimes wrong. Best safe side is first to try direct minimization. Next one indirect minimization. If any there, no, then go for substitution. Go for substitution. In the substitution, identify any minimization you can do. Right? Identify any minimization you can do in the substitution. If at all that is also not there, right? That is also not there. Substitution also you can do. I done this. Now, if anyone want to do directly, you can do like this one. Do you want to do directly? You can do like this. How? See this one. See everyone. It is x1. All the left hand side people give different name. y1. It is a x2. Different you have to give. It is a y2. It is a y3. So just go to left hand side. Give for everyone different number. Go to left hand side, for everyone give different number. Now can you help you now? Can you help you now? You given different number. After giving different number, in the second line you are using first level people. What is the answer? This x means x1. This one. This one. Now in the third level you may use previous levels. What is the answer? Y means this y1. Right? Third level you may use the first level, second level people. Next one. Fourth level you may use previous level. See, there is no x1, there is no y1, there is no z. That's okay. Now in the fifth level you may use previous level. Right? Can you help me now? What the x means? What? Recent x, x2. Recent y, y2. So like that. So left hand side 5 new people came. Right hand side people who are not changed, just check. 1, 2, 3, 4, 5. So left side 5 people, right side 5 people, total 10. So you can do directly. Sometimes maybe 1 or 2 less will come. So best idea, do direct minimization if possible. Do indirect minimization if possible. So what, right? Lastly, you can go for substitution. Please check again, cross check any minimization you can do. Any minimization you can do, please cross check. Right? Please cross check. Other than this, nothing is there. Other than this, nothing there. Now see, some people are asking, sir, what are the indirect one? See this one. What are the indirect one? Listen everyone now. What is the indirect one? Everyone listen. See, this is the meaning of indirect one. Some people are asking, sir, what is the indirect one? Isn't that C into B? Isn't that C into B? Suppose isn't that C replaced by, right? Last level C into B there. Here C into B there. See, what is the meaning of indirect one? Here C into B there. Now, right? C replaced by A divided B. C replaced by A divided B. A divided B into B. See, both are cancelled. This is the indirect, right? This is the indirect minimization. This is the indirect minimization. C into B, C replaced by A divided B. I think divide B into B, both are cancelled. This is called indirect minimization. This is the indirect minimization. See, so indirect means while going, some people may cancel. Direct means two people are exactly equal. Direct means two people are exactly equal. How? Directly means two people are exactly equal. How? Like this. See this one. Like this. Direct means two people are equal. See this one. It is the A into B. Somewhere also A into B there. Exactly same. This is the direct minimization. This is the indirect minimization. After substitution, some may cancel. So these two, if you do, actually more than enough. Safe side, I done this also. Safe side I done. If you do direct, indirect, that is more than enough. Safe side I done this also. How? I substituted. Any minimization possible I verified. So I got to know that nothing I can do here. No cancellation, nothing. Right? Just I think that time what you do because of nothing minimization. So one by one operation you can do. Right? Inner bracket you do first one. Next inner bracket, next inner bracket. Like that you can go inner brackets one by one. Like that you can go inner brackets one by one. Right? Fine. So finally 5 temporary variable, 5 normal variable, totally 10. Totally 10. Right? Totally 10. Right? I'm thinking that totally 10, it's fine. Now go to the next one. We done many problems in the class also. See this one also. We done many problems in the class also. See this one. Unlock 2, right? Unlock 20. So today and tomorrow, right? I think today and tomorrow, right? 31st. Today and tomorrow means 31st. If you use the referral code Reddies live, 30 and 31st, if you use the referral code Reddies live, right? Today and tomorrow, you will get 20% discount. Please use it. If anyone want to join. So if you go for Iconic, personal coach you will get. Personal coach. Personalized test analysis will be there. Study planner with right by weekly reviews also possible. Subscribe now. Next one, right? Ascend batch is starting from 2nd Feb onwards. Right? If anyone want to join, they can join. Next one, Evalu batch also starting, right, from 2nd Feb onwards for 2023 people. Right? If you want, you can join here. Right? If you want, you can join here. Next one, Spark batch also starting for 2023 people. You can join. In that, TOC starting from 2nd Feb onwards. TOC starting. Next one, Vero batch also going to start from 2nd Feb onwards. Right? For 2024 people. Those people who want to join in 2024 gate preparation, you can join. Use the referral code Reddies live. Next one, foundation course also going to start 2nd Feb onwards, right? So for 2024 people, so they can go ahead. Aptitude going to start. Yeah, can you see this problem? See this problem. Solve this problem. Suppose implementation supports an instruction reverse which reverse the order of the elements on the stack, in addition to the push and pop instruction. Which one of the following statement is true with respect to this modified stack? Can you do this? So can you check this? Suppose implementation, right, implementation of stack supports not only push pop, there is a reverse also. Implementation of stack supports not only push pop, reverse also, which will reverse the elements. Then which one of the following statement is true with respect to this modified stack, right? So option a queue cannot be implemented using this stack. Whenever with two operations of stack itself you can implement queue, why can't you implement queue with three operations? So A is wrong, everyone know. A is wrong, everyone know this. He is saying queue cannot be implemented using this modified stack. No. Next one, a queue can be implemented where NQ takes a single instruction, NQ take a single instruction and DQ take a sequence of two operations. So he is saying that if you implement the queue using stack, using this modified stack, NQ takes single instruction, DQ take a sequence of two instruction. C is saying that a queue can be implemented where NQ takes a three instruction and DQ takes a single instruction. Right? Next one, option D saying a queue can be implemented where both NQ DQ take single instructions each. Right? It is not possible. Single instructions each not possible. So this also you can cancel. With single operation, how queue possible with using stack with single operation? It is not. So what is the answer you are thinking? If anyone knows to this problem, what is the answer you are thinking? Can you check? So what is the answer for this? Let me try this. Many people know. If anyone don't know, can you see this? Many people know. If anyone don't know, can you see this? See this one, interesting answer. Can you see this? See everyone, can you see this one? So this is, listen everyone now. This is stack. Everyone listen. It is the stack. It is the queue. You are implementing queue. Please be careful. You are implementing queue. Everyone be careful. You are implementing queue. Right? Let's see. Whatever I will do in this queue, same thing I should do with the stack also. How I am doing? Please listen. Whatever I am doing in the queue, same thing you should do in the stack also. See how I am doing. In the queue, first I kept A. In the queue, next I kept B. In the queue, next I kept C. In the queue, next I kept D. This is the queue. So if I say Q, DQ, A is coming out. If I say DQ, A is coming out. If I say second time DQ, B is coming out. Same thing, listen, same thing I want to do in the stack also. Whatever I am doing in the queue, same thing I want to do in the stack also, because that is the meaning of implementing queue using stack. Whatever I am able to do in the queue, same thing I should do in the stack. How? Let's see. Everyone listen. If I say DQ, A should come first. Afterwards, B should come. Please be careful. Right? Now see the answer. Stack I can do push and pop. Using push, pop and reverse also. Implementing this how? Listen, very simple. Now. Very simple. First I done the right push A. See this one, push A. But remember, in the case of the stack, if I say pop, last coming, but I want to first to. In the case of stack, if I say pop, last coming, but I want to first, because Q will give first only. But in the stack, if I say pop, last coming, but I want to first only. How? Nothing is there. Listen, nothing is there. First A is there. First, right? First push A I pushed. Now listen, if I push once again B, top of the stack B is there, but I want A. So what you do is nothing there. Listen everyone now. When you are implementing NQ, using stack, right? If you push one element in the stack, you should do one thing. What is the answer? Already A there. I want to NQB. NQA I already done. NQA means push A. That's okay. But NQB means push B. If I do push B, top of the stack B is there. If I pop, B is coming. But I want A. So what you do is very simple. Whenever some NQ is going on, you should do like this one. How? Listen, whatever elements are there, NQ when you are doing, whatever elements are there, first to reverse it. When you want to do NQ in the stack, first whatever elements are there in the stack, reverse it. A reverse is A only. After reversing is over, just reverse it. Yes, I done the reverse. After reversing is over, push B. I kept B. Push B. After push B also over, then again reverse it. Two time reverse. Then it became B, right? I think AB becomes, right? I think reverse BA. Now if you want, you can check top of the stack is always first element. So listen everyone, now when you are doing NQ using stack, what you do is, don't do directly push B. So what you do is, first reverse whatever there. In the stack whatever there, first to reverse it. Yes, I reversed. Then push your element, whichever element you want to push. NQB. If you want to do, first to reverse it, then push B, then again reverse, two time reverse. So that top of the stack always contain your element. Means first element. Those people who are not getting, let me do one more time. I want to do NQC. Listen, I want to do NQC. First to reverse it. If you reverse now, BA is there. If you reverse now, it will become AB. First to reverse. Yes, I done the reverse. AB. After reverse AB, then push element C. Then element C also push. Then again reverse it. What is the answer? C, B, A. Right? Like that. So that top of the stack contain always first element. Now if I say DQ, what is the meaning? DQ means simply say pop. DQ means pop. A. So what I want to say is, listen, if you implement Q using stack, where stack supports reverse also. Normal stack supports push and pop, but this stack supports push, pop and reverse. So you can implement Q using stack. In such a way that NQ operation will take three things. DQ will take one only. See this one. One DQ is nothing but pop. So let me write the code also. Roughly I will write. Because of lack of space I am not writing. Right? Let me write the code roughly. See, this is the code. If anyone having small doubt, this is the code. NQ element X. So you are implementing Q using stack. When you are implementing Q means what? NQ DQ. When you are implementing Q means NQ DQ. You are implementing Q means NQ DQ. So using stack, see, NQ of X is equal to first reverse the stack. Reverse the stack first. Then push X. Then again reverse it. After push of element X over, again reverse. This is the NQ code. It is the first step, it is the second step, it is the third step. Now when you say DQ, simply pop. Pop yes. What is the meaning? From the stack you are popping. So this is the code. So listen everyone, this is nothing but, this story is nothing but implementing. This story is nothing but implementing Q using stack, which supports three operations: push also, pop also, and reverse also. Careful, and reverse also. implementing queue using stack which supports push pop reverse. When you say implementing queue, NQ DQ. When you are saying implementing queue, NQ DQ, NQ can be implemented using stack, right, with the help of 3 operations. DQ can be implemented using 1 operation. DQ can be implemented using 1 operation. So answer is going to be, answer for this problem is going to be, what is the answer? Answer for this problem is going to be second option. Answer for this problem, second option. If anyone is not getting, can you concentrate little bit? If anyone is not getting, just concentrate. This is the code. If anyone unable to concentrate, this is the code for this. This is the code for this. Previous problem, if anyone unable to understand, this is the code for this. This is the code for this. This is the code for this. Just this is the code for this. Yeah, if reverse not there, 2 stacks required. Dushyant, if reverse not there, 2 stacks required. If reverse not there, then 1 stack extra needed. True. True. If reverse not there, 2 stacks required. Someone still thinking about postponing GATE exam. Someone still thinking postponing GATE exam. How can you think like this? All are seriously preparing. All seriously preparing GATE exam. Everyone doing revisions and all. How you think about postponing? All are revising. All are doing great revisions. How can you think like this? Now suppose P, Q, R, S, T are sorted sequences having lengths 20, 24, 30, 35, 50 respectively. They are to be merged into a single sequence by merging together 2 sequences at a time. The number of comparisons that will be needed in the worst case by optimal algorithm for doing this. I think if you observe clearly, they are to be merged into a single sequence, merging together 2 sequences at a time. The number of comparisons that will be needed in this worst case by optimal algorithm. It is something like merge algorithm. This problem related to merge algorithm. This problem related to merge algorithm. Worst case comparisons. Worst case comparisons. This problem related to merge algorithm, worst case comparisons. This problem related to merge algorithm, worst case comparisons. They are to be merged into a single sequence by merging together 2 sequences at a time. The number of comparisons that will be needed in the worst case by optimal algorithm for doing this. Right? By optimal algorithm by doing this. So if you want to get the worst case comparisons, it's okay, but optimal algorithm is saying, can you help me now? Who are the 2 minimum? Just I think maybe I am thinking it is a combination of optimal merge pattern and one more thing is merge algorithm also. Optimal merge pattern, merge algorithm also. Let's follow that. Can you say who are the 2 minimums here? Instead of taking any 2, just to take 2 minimums. Because optimal merge pattern will give optimal minimum number of moves and all. He is asking optimal algorithm. He is asking optimal, not only merge algorithm, he is asking optimal algorithm. Let's see that. Can you help me? Who are the 2 minimums here? 2 minimums. I think 2 minimums, if you see 358, I think 438. These are the 2 minimums. Merge them. Sorry for this. Right? Who are the 2 minimums here? See the sequence and start. I think this is the sequence. Take 2 minimums. I think if you take the 2 minimums, 20, 24. 20, 24. Merge them. If you merge them, you will get the 44. It's okay. But I think comparisons in the worst case is 43 comparisons. Careful. 43 comparisons. Until now, 43. When you merge them, worst case comparisons are these many. right? I think 24 is completed, 44 elements came, that is okay, right? Comparison happened until now, worst case is 43. Now again, in the available people, if you see available people, 44, 30, 35, 50, again two minimums. Again two minimums. What is the answer? 44, 30, 35, 50. I think 30, 35. Next minimums are 30, 35. It is the combination of merge algorithm also and optimal merge pattern algorithm also. 30, 35 is 65. Comparisons are 64. 64 comparisons. So 30, 35 is over. 65 is came. Now in the available people, again two minimums. In the available people, again two minimum. I think this 44 and 50. Merge them, which became 94. But comparisons are 93 only. Now again, I think these two people are gone. 44, 50 becomes a 94. Now these two again merge them. These two again merge them. 94, 65. Which is going to be 150, 159. Check once. Right? 150, 159. So 158 comparisons. Here 158 comparisons. Add all of them, you will get the answer. First to 43, next to 64, next to 93, next to 158. Add all of them. 7 plus 3, 10, 18, 10, I think 15, 21, 25, 358. 358. I'm thinking 358 is the answer for this. I'm thinking 358 is the answer for this. Please, can you verify? Can you verify now? Take two minimums. 20, 24, 44, 43 comparisons. Next two minimum. Next two minimums. Next two minimums. 30, 35, 65. Right? 64 comparisons. 64 comparisons. 64 comparison. Next one, next to two minimums. So if you do small, it is the optimal. See, optimal algorithm means optimal merge pattern. Merging also there. Merging also there. Optimal merge pattern also there. So answer is 358. A is the answer for this. A is the answer. A is the answer for this. It is a nice problem. Please take care. Suppose, listen everyone now. Listen everyone now. Same question. Worst case not given. Best case given. Same question. Worst case not given. Best case given. Then what you do is, same problem. Worst case not given. Best case given. Best case given. Then what you do is, do like this. Do like this. See this one. I think it is not 43. Right? It is not 43. Minimum of 20 will come. Minimum of comparison, right? So minimum of 44, right? See this one. 44 moves are there, but comparisons are minimum. Again, comparisons here 44, 50 minimum, right? I think minimum comparisons are 44. Next one here 30, 35. Minimum is 30. Next one here 94 and 65. If you merge 159, I think it is going to be 65. Add all of them. 20 first, 30 next, 44 next, 65 next. Add all of them. 9 here, 10, 13, 15, 159. That time 159. That time 159. If at all they will ask you minimum comparison, 159. Minimum of 20, 24. True. If they ask you minimum 159, if they ask you maximum, but remember optimal algorithm. What is the meaning of optimal algorithm? While taking, don't take blindly. Take two minimum people. So optimal algorithm means don't take any two. Just take two minimums. Next take next two minimums. Next take next two minimums. Right? Next take next two minimums means this one. Next minimum. So what is the answer? Next minimum is this. Lastly take next minimum like this. So optimal algorithm means this one. But when you say worst case comparison, then I think 1 difference. When you say best case comparison, minimum you take. Minimum of these 20. Minimum of these 30, like that. So it is a nice problem. This kind of thing you may expect in the GATE exam. This kind of thing you may expect in the GATE exam. Please take care. Please take care this problem. This may be you can expect in the GATE exam. Right? See this also. See this one also. Right? Can you see this one? What is the answer of this problem? What is the answer of this problem? Can you check? Arey Durga, please, whatever class happened, see the revision one time. Why you want that PDF? Just see the revision one time. Listen the video one time. Listen the video one time. That is enough. Listen the video one time. That is enough. Yeah, good evening Arnav. Suppose there are log n sorted lists of n by log n elements each. The time complexity of producing a sorted list of all these elements is, use a heap data structure. Use a heap data structure. So using min heap we done, using med sort we done this, then answer you will get A. Med sort if you do, you will get this. If you do med sort, you will get this. Using med sort, you will get this. N log n. Using med sort, you will get this. N log n. Using med sort, you will get n log n. But here, using heap data structure means using min heap or max heap. Using min heap or max heap, we should do this. Using min heap or max heap, we should do this. Suppose there are log n sorted lists of n by log n elements each. The time complexity of producing a sorted list of all these elements is. Using heap data structure is asking, not med sort, using heap data structure. Using heap data structure. Using heap data structure. So what is the answer? Using heap data structure is asking. Yeah, what is the answer for this one? I think how many groups are there? Log n groups are there. Log n sorted lists, each of size n by log n. Every group contain n by log n, but log n groups are there. See this one. It is the first group, it is the second group, it is the third group, it is the fourth group, and so on. Log n groups are there. So log n group, and everyone is sorted. Here few elements are there. How many? N by log n. Here 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 n by log n. So log n groups are there. Every group contain n by log n elements are there. N by log n elements are there. Every group contain n by log n. Now this is the final one. This is the final one which I want single sorted array. This is the final. So every group contain n by log n. Groups are log n. N by log n into log n becomes n. So total n elements I want here. N elements sorted here. I want n elements sorted here. So how to do this, right? Very simple. I think here I want to first minimum. Here I want to overall second minimum. Here I want to overall third minimum. So overall first minimum, overall second minimum, overall third minimum. So can anyone help Can anyone help So how to get the overall? Because every group is sorted. Every group having one minimum. First person is minimum. Every group having first person minimum. Every group having first person minimum. Every group having first person minimum. I don't want first person. I want overall minimum. What is the answer? Nothing. From this group first person. from this group first person, from this group first person, from this group first person, every group first person, right? Every group first person you take. Every group first person you take. How many people are there? Log n people will come. Every group first person you take, log n people will come. Just apply build heap. Just apply build heap. Every group first person you take, just to do build heap. Build heap n people n time, build heap log n people log n time. Build heap will take log n time. Every group first person take, just apply build heap. Build heap n people will take n time, log n people will take log n time. After log n time is completed, you got the mini heap tree. From this mini heap tree, delete one time, you will get first minimum. So one deletion will take log n. N elements mini heap if you delete log n elements mini heap if you delete log n. One time you delete log n. Right? I think right? Next time also one more time you delete one more log n. Next time one more time you delete, right? Every time one minimum is coming. Every time one minimum is coming. One more time you delete one more log n. One more time you delete one more log n. Like that. For every element log n, like that n time, it will leads to n log n. N log n. Using heap sort also same answer. Using med sort is n log n. Using heap sort also n log n. Using heap sort also n log n. Right, true Saurabh, that is exactly. Saurabh, exactly like that. Take every minimum person, construct min heap. Take every minimum person, construct min heap using build heap. Build heap for n people n time, build heap for log n people log n time. Build heap n people will take n time, log n people will take log n time. Log n people take log n. Now, after getting the min heap, delete first time, first minimum came. Right? Continue like that. Second time log n once again. Third time log n. Fourth time log n, and so on. But remember, first minimum purpose only first people are fighting. Second minimum purpose, right? I think you have to increase one by one. Here also one by one. Here also one by one, right? Every group one element is keep on increasing. Every group one element is keep on increasing. So every time what happened is one insertion you should do. Every time one insertion, one deletion. Every time one insertion you have to do log n. Every time one deletion you have to do log n. Insertion is log n, deletion is log n. Totally every element required 2 log n. Every element required 2 log n. Every element required 2 log n, like that n times. So 2 into right n log n, which will goes to 2n log n, which will goes to n log n. Answer is option A. Using med sort also same answer. Using heap sort also same answer. Heap also same, merge also same. One time log n plus log n for right n times, right? 2 log n for n time. Or now 2 log n for n time. One time log n. Next time onwards 2 log n, because every time one new element will be inserted, one element will be deleted. Every time one new element will be inserted, right? Every time one new element will be inserted, one element will be deleted. One element will be deleted, right? Like that. So anyhow, mostly everyone know. Just I want to give rough diagram. Right? See this also. Don't by heart anything. Meaningfully study. Because within the syllabus only will come. Within the syllabus only will come. Within the syllabus only will come. Don't by heart. Meaningfully study, it is enough. Don't by heart, meaningfully study, it is enough. Yeah, what is the answer for this? What is the answer for this? Can you check? Right, so because it is a sorted, right, because it is sorted, so let me use red color. Yeah, it is sorted one. If it is sorted one, if you take first element as a pivot, what is the first element in the sorted array? First in the ascending order, if you take first person as a pivot, means first minimum. If you take first minimum as the pivot, after partition algorithm is over, it will go to first place. What is the meaning? First place your element will go, left side 0, right side all will come. Again here also, if you take first person as a pivot, right, left side no one will go, right side all will go, n minus 2. So it will leads to unbalanced tree which contain n levels. It will leads to unbalanced tree which contain n levels. Every level partition n time. Every level partition n time. Every level partition n time. Right? Every level partition n time. Yeah, every level partition n time. So n time, right? N, right? N times. So n times n square. This will leads to n square comparisons. Partition algorithm every time n approximately n square. Next one, if you take the next one, I think it is the descending order. In the descending order, if you take the first person as a pivot, in the descending order, first person as a pivot means largest element you are taking as a pivot, it will go to last place. Largest element if you take as the pivot, it will go to last place. When you say it will go to last place, what is the meaning? Left only all will come, right 0 will go. Something like that will happen. Next round also something like that. N minus 2, 0. Next round also same, n minus 3, 0, like that. So everywhere partition n time, right? Like that, n rounds will happen. Unbalanced tree. So that is also n square. So answer is going to be C1 is equal to C2. Answer is C1 is equal to C2. I'm thinking, right? So you are comfortable. So, and one more thing also you can write. One more input also, that is all elements same, 10. All elements same also you can write, right? This is also sorted order. It is also n square time. Assume that it is a C3. So C1 is equal to C2 is equal to C3. C1 is equal to C2 is equal to C3. Ascending order n square, descending order n square, right? Next one, same element, then also n square. So you have to calculate. He don't ask you, right? Gaurav, he don't ask you. Normally SPAPs he don't ask you, right? I think mostly comparisons only will ask. If SPAPs he will ask, right? In the classroom notes there, please verify. If last element is in the pivot, same story will happen. Left gap becomes right gap. Right gap becomes left gap. Same. First element as a pivot, last element is a pivot, nothing will change. First input becomes first input becomes second input becomes first input. And one more, listen, these two inputs will go to best performance. These two inputs, right, will go to best performance if you take middle person as a pivot. If you take middle person as a pivot, it will go to balanced partition. If you take middle person as a pivot, balanced partition, then n log n will come. If you take middle person as a pivot, then balanced partition will come. Then n log n. First one no use, last one no use. Middle person if you take, then n log n. If you take middle person, then n log n. Right? If you take the middle person, n log n. Because it is already sorted. Middle person is nothing but a median. If you take median as the pivot, n log n time. First one as the pivot, same answer. Last one as the pivot, same answer. Middle person as a pivot, difference will come. Middle person, then difference will come. middle person, then difference will come. Yeah. Can you see this program? What is the time complexity of this program? Can you see this program? What is the time complexity of this program? What is the meaning of if they said one is best, one is worst? What is the meaning of what is best, what is worst? For this problem, what will be the time complexity? For this problem, what will be the time complexity? Check once. So right, so Fn will take time complexity, F1 will take time complexity Tn, Fn will take Tn, right, Fn by 2 will take Tn by 2, Fn by 2 will take Tn by 2. Remaining no loops are there. See, remaining small work here, small work here, small work here, remaining no work, right, which will take constant. Time complexity means loops, so it will goes to 2Tn by 2 plus C recurrence relation. Solve it, you will get the answer n. You will get answer n. Right? Just write the recurrence relation and solve it. Just write the recurrence relation and solve it. Time complexity means loops. 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 Right? Time complexity means loops. No loop is there. See this one. In this area also see. In this area also you see. In this area also see. No loop is there. See, n less than or equal to 1 return. So you may be returning this value, but no loop is there. Constant. If also constant, else also constant. Normally we don't concentrate if. Right? Fine. So in the recursive program, if no need to bother, because that is only for termination. So remember, right? Remember. I think Kiran said correct. Thank you, Kiran. Kiran said correct. Yeah, yesterday Kiran asked me something, right? Kiran, right? So, right, non-REL complementation is maybe non-REL, may not be. Right? Non-REL complementation may be non-REL, may not be also. Right? Right, that is, you asked me, so at that time, right, I have some dilemma, so I said I will verify and I will check. So yeah, you are right, whatever you are saying true. Non-REL complementation, maybe non-REL, maybe REL, okay, right, anything happened. Right, now come back here, right. So answer for this one is going to be 2Tn by 2 plus C, which is nothing but n. So everyone remember, non-REL complement need not be non-REL. It may be non-REL, it may be REL also. It may be REL also. Right? Now go to the next problem. Because of not required, I didn't study that, but anyhow I went through one more time. Right? Fine. Now can you say what is the answer of this? For the undirected unweighted graph given below, which of the following sequence of edges represent a correct execution of Prim's algorithm to construct a minimum spanning tree? Can you check? Can you check this? Arey Akash, see the classes, classroom notes you see one time. Akash, see the classroom notes one time. See the classroom notes one time. Try once, whatever it is, right? Yeah, it may be childhood question, but it may be expected. It may be expected, right? One time check. One time check. One time check. So can you help me now? What is the first minimum among all? So Prim's algorithm, listen, Prim's algorithm, remember, it is a Prim's algorithm. It is a Prim's algorithm. Remember, it is a Prim's algorithm. So can you help me now? Can you help me now? Prim's algorithm, while checking Prim's algorithm, first check adjacency, then check minimum, adjacency and minimum. First check adjacency, then minimum. Adjacency and minimum. Adjacency and minimum. While checking the Prim's algorithm, first check adjacency and minimum. Let's try adjacency. What is the adjacency? Can you help me now? AB. What is the next one? First AB is here. AB is here. So I think if anything is not visible, if you are not able to see, it is A, it is B, it is C, it is the D, it is E, it is F, it is G, it is H, it is I. Right? If anyone not able to see, please take care. Now listen. So first he took AB. Listen. First he took AB. After AB he took DF. See. After AB he took DF. See. First AB he took DFC. I think disconnected. Prim's algorithm never will give disconnected answer. So adjacency fail, stop it. Adjacency fail, stop it. No need to check also. Prim's algorithm will always give connected answer. Prim's algorithm will give always connected. So option A starting only fail. Option A starting only fail. Now see this one. See everyone. HG. Listen. HG, GI, see, G common, that is the meaning of connected. Next one, I think H common, right? Old one, new one, connected. FC connected, FD connected, D, right? D and D connected. Next one, AB connected. Next one, CE, somewhere C there, connected. So option D connected. What is the meaning? Adjacency satisfied. Let's go to option B. CE, CF, I think C connected, F connected, D connected, A connected, G, I think see this one, see everyone now, G, before that any G, no, before that no G, before that any H also there, no, I think here disconnected. So B also cannot be the answer, disconnected. Now let's go to the C. DF and FC, F connected. I think next one is going to be D, I think connected. Next one is A connected. Next one is C connected. Next one is F connected. Next one is G. I think G came till I think H connected. Next one G connected. I think if you observe clearly, right? So I think C and D satisfied adjacency. C and D satisfied adjacency. I think who failed? AB failed. C and D pass. Now in the C and D, who will satisfy minimum? We have to take care. Let's go for minimum also. C and D satisfied adjacency. Let's go for minimum. I will try. If I want to try minimum, edges required, right? So I think if something not clear, I am writing edges 6 here. It is also 6. It is 1. It is 7. It is 3. It is 5. It is 10. It is 2. It is 7. It is 8. It is 3. I think it is also 8. It is 12. These are the values. If edges are not visible, please let me know. Right? Now let's check. Now one by one, everyone listen. Right, min property also we have to verify. Min property also we have to verify. I will verify now. Min property also I have to verify. I will verify now. Everyone listen. Everyone listen. Min property I am verifying. So can you help option C, option D, if you observe, option C, option D. Option C I am checking. First see this one. He started from D. He started from D. See this one. First option C. He started from D. Let's go here. D. Can you help what is the D adjacent? What is the D adjacent? See this one. I think DF, best one. Best one you have to take. DF. DF, best one. I think DF you taken. Now, DF you are taken, it's okay. What is the next one? D and F adjacent best people. D and F. You started from D. D adjacent people is F you are taken, it's okay. 2. Next best should be DF next best. D next best is going to be 5. F next best is going to be I think 3. So next should be FC. Yeah, FC. Next one is going to be Prim's algorithm will always give connected answer. Prim's algorithm will always give connected answer. Now can you help DFC, who is the best? DFC, who is the best? D next best is 5. F next best is I think 8. C next best is going to be I think 6. 2 6s are there. You can take any one. I think CA also, CB also. But unfortunately is taken DA. DA is the best answer because DA is 5 only. Yeah, perfect. DA is correct. Yeah, until now fine. Who is the next best? I think AB. Next best is AB. Yes, that is also fine. AB, that is also okay. I think next best is going to be, no need to go left side. Let's come to the diagram right side because left hand side people are all connected. Let's go to right side. I think D next best is 10. D next best is 10. F next best is 8. F next best is 8. I think C next best is 7. I think in my opinion answer should be right, C to E. Yes, I think this is. Next one, right? I think 12, 8, 10. Answer is 8. I think FH. Right, next one, right? I think in the available people, if you see, I think missing person is G and I. So I think answer is going to be 10, 7, 8. I think 7 is the answer. 10, 7, 8. 7 is the answer. HG is the next one. Right? HG. Next one is going to be, I think only one person left out, GI. I think perfect. C is perfect. So I think C satisfied min property also. Not only adjacency, min property also satisfied. Let's go for a D. Where D fail? Let's check. Where D fail? Right? Let me try once. Where D fail? I will try once. It is a 3. It is a 2. It is F. It is 7. Right? Let's see. Where is the D fail? I will try once. See this one. First HG. H adjacent. Can you help H adjacent, who is the best one? H adjacent. One side is H is 12. HF is 8. HI is 8. I think he is taken. H best person is HG is taken. I am happy with that. HG okay. Now I think adjacent people, if you see best one, I think FD. See, array it's a bacha. See this one. I think it is a bacha. I think after HG, sorry for this one. I think he is taken HG. Let's try. Yeah, he is taken HG. Right? HG means this side. Where is the HG? G is this one. I think 8 is there, 7 is there, 8 is there. I think HG. 7. Yeah, fine. Now perfect. Now can you help Next one should be GI because 3 best. This also okay. Next one HGI. Next adjacent people 12, 8. 12, 8, 10. 12, 8, 10. What the better? 12, 8, 10. I think 8 better. I think HF. This also okay. Now available people, what is the next best? I think FD. I think here problem came. Here problem came. He is taken FC. FC is 3, FD is 2. I think it should be FD. It should be FD, but he said FC. So min property failed. Min property failed. So D failed. If you are lucky, all people will fail adjacency. If you are lucky, all people will fail adjacency. Only C will pass. But you are unlucky in this problem. Two people passed the adjacency. So I went for min property also. Min property D fail, C pass. So C is the answer for this. C is the answer, right? C is the answer for this, right? Really nice problem. Please take care. First to try adjacency. Now can you help? What is the time complexity of this program? What is the time complexity of this problem? Can you check? Time complexity of this problem. Kruskal don't bother about adjacency, right? Just to take minimum. Prim's algorithm. See, sequence kind of questions will be given. Prim's only. Kruskal no one will give. Sequence kind of questions will be given from Prim's algorithm. Right? Kruskal algorithm, no one will ask any sequence because just taking minimum. What is so great in that? Yeah. So can you help? This program, what will be the time complexity? See this one. Inside if you observe. This program, if you see inside, if you observe, right? No loop is there. No loop. Time complexity constant. No loop is there. See this one. No recursion, no loop also. No recursion and no loop also. No recursion and no loop also. Right? Careful. This program time complexity constant. Can you help me? What is this program time complexity? Yeah, this program, if you see, this program time complexity, if you see, Fn time is Tn. Fn minus 1 time is Tn minus 1. Tn minus 1. Fn minus 2 time is Tn minus 2. Right? Remaining is constant. It will become Tn is equal to Tn minus 1, Tn minus 2 plus C. So if you solve this one using recursive tree method, if you solve this one, I think n level stack will come. It will goes to 2 power 0 C, 2 power 1 C, 2 square C, and so on. 2 power n C will come. If you solve this one, C into 2 power n, so answer is big O of 2 power n. So time complexity of this problem, big O of 2 power n. Time complexity of this problem, big O of 2 power n. time complexity of this problem big O of 2 power n. So careful this problem. Yeah, I'm stopping class here. I'm stopping class here, right? In next class we will see remaining things. If you really like this class, right? So you subscribe this one, right? Fine. Thanks. Good night. Thanks and good night.